Okay, so, last time I said I think it helps to think of validity as almost a game, and that's an approach we will, talk more about in coming weeks. And, it is useful though, because it is a good way of, I think, thinking about the form of an argument. Validity is all about the form. You know, Validity is not about the content. And I think that's one of the things, if not the main thing, that makes validity hard, right? When we're thinking about validity, we only want to think about what the argument says on the page, what is explicitly spelled out by the person. And we don't want to bring in anything we might know about what they're talking about. And that makes validity very hard because it's just natural to bring in what you already know. And a lot of times it helps us, right? With validity, we're not doing that. We're not thinking about, once we get really practice with this concept, what the person is even saying. We're just thinking about the form of the argument. Okay, so what do I mean by the form of the argument? Well, look, arguments that are about very different things can have the same form, right? And you guys have already noticed this with informal logic when we're diagramming arguments. An argument, you know, I might give you an argument that has three premises, all of which are independent support. I might give you an argument like that for saying that, you know, Wrath of Khan is the best Star Trek movie. I don't know, right? I might also give you the same argument for thinking that, you know, the Toyota RAV4 is a good car, right? Three independent premises about really different things, but they have the same form. They might look the same if you were diagramming them, right? With validity, it's the same way. But when we talk about validity, it's going to be all about form, right? We are no longer going to be thinking at all, at least ideally, what the premises are saying, but only about their logical form, the way the pieces of the argument fit together, not what those pieces are. All right, now that's a lot of like high altitude, hand wavy stuff. Let's get into some real examples. So dogs are descended from wolves. Moxie is a dog, so Moxie is descended from wolves. Donald Trump is president of the US. Every president is at least 35, so Trump's at least 35, right? Now, these are arguments about very different things, dogs and wolves, presidents and being a certain age. But if you start to think about it, these arguments actually have exactly the same logical form. All dogs are descended from wolves. Moxie is a dog, so Moxie is descended from wolves. All presidents are at least 35. Trump is a president, so he's at least 35. They actually both have this same form. All A are B. This category of A things, presidents or dogs or whatever, are all B, descended from wolves, at least 35, so on and so forth. X, this thing that is an A, Moxie, Donald Trump, Joe Biden, Princess Pretty Paws, Chester A. Arthur, whatever, right? Plug it in there. Lassie, plug it in. It's going to be a B. But you could use radically different things, right? You could plug things in here that you never have heard about before. And if it has this form, then you know it's a valid argument. All right. And so something I want you guys to notice, something, you know, you've seen that these two are valid arguments and they both have the same form. So imagine you came across an argument that had this form. All baryons are fermions. I had to do a little Googling and some like physics terms to get this. Don't worry. I'm not going to pretend I knew this off the top of my head. Neutrons are baryons, so neutrons are fermions. Now, I mean, you might just look and you might try to think through this, but if you didn't know what neutrons and fermions are, you could just say, well, okay, this looks like it has the all A or B form. X is an A or something like it, so X is a B or something very similar. Might have a slightly different one, but it's similar enough. You could say, well, look, if these are valid, this is valid too, right? And this is something you will see. If an argument is valid, then every argument with that form is also valid. Valid is all about the form. Once you know that an argument is valid, any argument that has that same form is also going to be valid. And if an argument is invalid, then any argument with that same form is also going to be invalid. Now, how do we show this? Well, we're going to get to some formal methods. We're going to get to some rules that will show this, next week. One way is through Venn diagrams when we're talking about categorical logic. We will talk about categorical logic for the next couple weeks. There are other methods with propositional logic, which we will talk about after that. But even at this level, one way of showing an argument to be invalid is to find a counterexample. And a more advanced way that works by finding a counterexample, but it's more general, is to show that an argument of the same form has true premises and a false conclusion. If the premises are true and the conclusion is obviously false, not just false, but hopefully completely bizarre and bonkers, so nobody would accept it. If the premises are true and the conclusion is obviously false, then the argument cannot be valid, right? Because if it were, true premises would mean true conclusion. So one thing you can do, if you're not sure about an argument, see if you can find an argument that has exactly the same form with true premises and a dumb conclusion. Here's an example. I'm using these nonsense terms I can't even pronounce, but let's give it another try. All Grieberts are snarks. Some snarks are bojums. Some Grieberts are bojums. Now look, you might be like, you might see whether this is valid or not. I'm guessing most of you don't. That's the point. What can we do, though? We can find and replace. So we have like Grieberts, snarks, bojums, all underlined. Let's go through and replace each of these. So we'll start with replacing Grieberts. All A are snarks, some A are bojums. Now we'll replace snarks, all A are B, some B are bojums, some A are bojums. Now we'll replace that. As long as we do it consistently, now we've got the form of the argument. Can we plug in stuff here for A, B, and C where the premises are true and the conclusion is false? Yeah, we can, right? All dogs are mammals. Some mammals are C. Some dogs, like we've doing this a couple steps at a time. We've replaced A with dogs and B with mammals. Now we just need to find something to replace C with that makes premise 2 true, right? Because premise 1 is already true. Some mammals are C. Well, what's something that some mammals are? But we want to make the conclusion false. How can we fill in 2 in a way that 2 is true and 3 is false? Think about it for a minute. What would you plug in for C here? I mean, there's a bunch of stuff, right? You could plug in mice, you could plug in ferrets, you could plug in squirrels, you could plug in platypuses. I just plugged in cats, right? All dogs are mammals. That is true. If you don't believe me, go look at a very basic biology textbook, right? Some mammals are cats. Yep. Cats exist. Cats are mammals, so some mammals are in fact cats. So some dogs are cats. Obviously not. No dogs are cats. That's stupid. Well, here we have an argument. True premise, not just false, but absolutely stupid conclusion. If that's so, we know this argument cannot be valid. And if this argument's not valid, well, we know that all arguments that have this form are not valid. So since the original had that same form, we know that it's not valid either. This is what Smith is a little advanced, but he does a better job covering this idea than I think Van Cleve does. So that's why I gave you Smith. He does this pretty quick. He doesn't do the step-by-step method, which I think is kind of bad because one of the things I want you guys to learn in logic is step-by-step. But this find and replace and try to find an argument with the same form, with true premises, flat out false, hopefully even just stupid conclusion, as a way of showing an argument form is invalid. That is one method, and it's a useful one. Now you guys are probably thinking, okay, how do we show that an argument's valid if it is valid? Well, right, if you can show an argument's invalid, then you know it's not valid, but suppose you can't show that it's invalid. Do you know that it's valid, or is it just you're not clever enough to show that it's invalid? Well, that is a real problem. It is one we will start to address next week. We will start to learn methods to show that arguments are in fact valid. Now note, inductive arguments aren't either or. They're not valid or invalid, but the form there is also important. And if you can do something like this for an inductive argument, it doesn't prove in the same way that it's invalid as it does with deductive arguments, but at least strongly suggests that it's not a good inductive argument. If you can find an argument with the same form, true premises, obviously false conclusion, it's not for inductive arguments, a stake through the heart in the same way it is for deductive ones, but it's pretty good evidence if the premises are obviously true and the conclusions obviously false. Well, that would be possible, right, with inductive arguments, because there's always a chance, but it's not usual, so that would at least show that this is likely not a good argument. Here's an example. This is an old one. The vast majority of serial killers have viewed pornography, so viewing pornography likely makes people more violent and prone to murder. This is a very common argument. Look, I don't know whether this is true of pornography or not. I tend to think it probably isn't. I don't really care. I don't have a dog in this fight, as they say. But my point is, this is a bad argument, right? And you can think of two obviously stupid arguments that have the same or similar form. The vast majority of students who fail linear algebra wear shoes to class, so wearing shoes to class probably makes students worse at linear algebra. Seems like the same form, not a very good argument. Vast majority of students who fail linear algebra are math or science majors, so being a math or science major probably makes you worse at linear algebra, right? That's also a bad argument for reasons you can think of. So with inductive arguments, this find an argument with true premises and an obviously false conclusion, it's not the knockout punch it is for deductive arguments, but it can at least suggest, very strongly suggest, that an inductive argument is in fact not a good one. All right. But what exactly is the form of an argument? There's different ways to try to bring out the form of an argument in deductive logic. The oldest version, which Aristotle, a philosopher 2,500 years ago or so, very bad with dates, but a very long time ago, maybe it was 23. I don't know. I could never keep the dates quite straight, but a very long time ago, Aristotle came up with this method of categorical logic. It was the main way of doing this for most of Western history. It's now been replaced by propositional logic, but categorical logic is a good place to start. It still works for most cases. We'll talk about some things it can't do, but we will start with categorical logic next week, and learning this categorical form will help us to see what the logical form of different arguments are. Now, my arguments here, I've put something very close to categorical form, if not categorical form. One of the things once we learn these forms, when people write out arguments, they usually don't put it in these forms. So you're going to have to do a bit of translation, a bit of rewording a lot of times to put it in categorical form. But we've already been doing this with informal arguments and distilling. It's just taking this a step further, and it's just, you'll see, having a bit more of a precise and rule-governed form. Anyway, we will start doing that next week. This week, I just want to get this concept of validity nailed down and this idea of argument form in deductive logic, because both of those are pretty tricky and they're both incredibly important. You're just not going to be able to do deductive logic without them. All right, so that's really all I want to talk about for this week. We will do a lot more practice with this in class.